Okay, I'll try to actually respect the 5 minutes. So normally I was not supposed to do this job, and maybe because I was talking too much, and so therefore they have appointed me to do the job. Alex left yesterday the meeting room, so I'll try not receiving your tomatoes this morning. First thing, we would like to thank the participants because really it was a lively discussions, and I think this is needed if you are addressing a new topic, even though from the various presentations it's not that new, but that we wanted to do something with the thorium is coming back, and so this was a very interesting aspect. First of all, we had the presentation in session 2. The first presentation was by Dr. Vijayan, who reminded the strategy of Homi Bhabha of the 3 stages, which is the basic, stages for India nuclear power, and I think we have to look to that with respect because it's a very long-term application of this strategy, with the final goal to get to introducing thorium at large scale. And this is also showed during that presentation that they are mastering the full elements of the fuel cycle. Fuel fabrication, reprocessing, using in the thermal reactors, breeding in fast reactor. So this confirms this 3 stages approach. They mastered the fuel cycle and also considering advanced reactors for the development. And so, and as you have seen today in the last presentation, even the ADS is looked at and have a certain role as a final stage eventually in the system. Then we had a presentation by Dr. Rob Arnold that presented a scenario study for UK deployment of nuclear or rebirth of nuclear power. They are a nuclear power country, and where he showed us that 3 scenarios were looked at, but mainly based on uranium-plutonium fuel cycle. And in the second part of the presentation, he addressed the thorium through the molten salt reactor, and this is in the frame of the European project EVOL. Then there was a very nice talk by Professor Raj Segal, and he said, well, thorium is feasible, honestly, but is it desirable? That's the question. And so I picked the one of his concluding slides and a recommendation, and I pointed out some elements in there. It's prudent to develop alternative cycle to the UPU. The thorium cycle doesn't provide an efficient platform to burn, transmute, and transmute plutonium. It does provide. But he says also, on the longer run, it can also burn the uranium-233, which is formed from the thorium. So, he says, a mission of disposal of accumulated plutonium could justify to start the thorium cycle. And I think this is, I would say, a rational approach to not, as it was just said before, we can't say from one day to another, hey guys, all what we have done, we have to throw it away, and we invent something from scratch. And this gives us the progressive introduction of thorium and having a justification for it, even in the present fleet of reactors. And so, nevertheless, he pointed out that when we are dealing to these introduction of the thorium cycle, we need demonstrations, we need prototypes where public money should come in. Then this Alex Miller position on my talk, I am not feeling comfortable to read that he's saying, I can't make my propaganda for myself. So I leave you that the only thing he says that Mira being for advanced, maybe we have to concentrate in this idea of ADS to realize at least one project to show whether this is doable, have an added value or not. But there were other important points, and Dominique Greneche reminded the audience that like any other technology, the thorium cycle based nuclear energy has also drawbacks, because many, many talks were, I would say, putting forward the positive part of the thorium, but he reminded some of the drawbacks. And I believe personally that the warnings, even though he was too sharp, and this morning discussion it was, but that's Dominique. The people who doesn't know Dominique, maybe they found this is a strange way of doing, but this is natural for him. But he says also things that we have to take seriously in those remarks he have put to us. Beautiful lesson on the great advance in the physico-chemistry was given to us by Paul Madden, and among other, the atomistic modeling, because we don't have so much data on the thorium, and maybe the advanced modeling can help us in improving our knowledge. And so this was very illustrative on how also modeling can help us and not relying only on experimental. Nevertheless, he said also that validation by experiments is needed. And these kind of research that have been presented in there can lead indeed to a commercial application, and Kirk was illustrating that by the FLIB LFTR strategy development. But to my opinion, and this is my remark, I think we should not forget that whatever fantastic reactor we will develop, it needs to be licensed. And we have not to forget that the licensing for civil application is really, I would say, a demanding effort. So I saw some of the plannings and agendas that are very optimistic, to my opinion. And so please don't forget this aspect. Luc van den Durpel from Areva delivered to us two good news. Big industries are now interested to do something with thorium. And he announced as this association between Areva and Solvay, two big industry groups having big knowledge on thorium. The chemistry of thorium by Solvay, the use of in nuclear energy by Areva. So this is a very interesting and important collaboration. The second good news is that the two groups are investing in R&D program and have even invited the audience, those who are willing to participate or to bring something for their development strategy are very welcome. But on the other hand, it was also clearly said by Areva that in their strategy of the fuel cycle, they doesn't want to mix the uranium-plutonium fuel cycle with the thorium-uranium fuel cycle. A second thing, that the thorium-uranium cycle should be introduced progressively in the existing reactor fleet, and we should not jump to, something that we have to invent. And third, he said also that from the perspective of Areva, this is a very long time endeavor, beyond 100 years, because today's reactors which are put in place, there are 80 years operational time. So you can imagine that indeed this is not a nonsense. Well, people that are in research, etc., they want to see things moving rapidly, faster, etc. But there is a dimension of industry which is also a reality that we have to take with us. It doesn't mean that it excludes that we should not start any research and development up to demonstration level. But we have to listen to our colleagues from industry when they talk to us. not to accept all what they say. We can't be challenging, but I mean, we have also to be realistic. Then we had Professor Muammer Kaya from Turkey, who announced that... Die? Okay, no. But also, sorry. But also based on the uranium-plutonium fuel cycle, whereas the country is the second largest country with reserves of thorium, as he showed to us, and therefore they want to wake up the decision makers of Turkey that maybe there is something to do with thorium, and they aim to create the Thorium Research Center in Turkey. Tony Donaldson from Rolls-Royce presented the full review of the advantages and disadvantages of the SMR thorium-based reactor for commercial application. He warned us on what is not to take, easily or too easy. And it was a fully, I would say, what I appreciated, neutral approach, no pro, no anti, but in clear way he showed us what is the situation. And finally, we in this session 3, Dr. Jan Uhlir from the Czech Republic, he presented the program of the Czech Republic in the MSR and the pyro reprocessing on LEF-based fuel. He said as that this is a very long-standing, withstanding program, and you see what I put here from the Czechoslovak time. But the good thing, he also told us that since 2000, there is a renewal of interest in this technology in the country, thanks to the engagement of the Ministry of Industry and Trade that allowed NRI and other Czech partners like Škoda Nuclear Machinery to be important player in the various European projects dealing with molten salt reactor and the pyro reprocessing. I listed the last FP5, FP6, and FP7 project. And the objective of the Czech Republic is to position this Czech program on material research, pyro reprocessing, even test in the test reactor LR0 in NRI, and also reactor design in a larger international framework. And I think that Jan have a very good news that he received only half an hour ago, that the ministry is putting back money in this program. Congratulations, Jan. So that's, this brings me to the end of my summary.
Well, thank you very much, Hamid. So, are there comments or questions on what you just heard from Hamid? One there, gentleman there. Could you please just state your name before you ask questions?
Yes. Hi, I'm Nikhil. I have a comment on the proliferation resistance of thorium. I appreciate what Dominic said, that thorium is more proliferation resistant. That's agreeable, but then I also feel that this proliferation resistance, I don't find it a very good, it doesn't have a very strong point, because the high energy gammas can anyhow be shielded and the job can be done for whatever it can be done. Or alternatively, one can also denature the plutonium. So I would say it is more of a political point than any of a scientific point.
I agree with your remark. To my opinion, the proliferation, okay, you can try to make it difficult, complex from the technical point of view. But at the end of the end, it stays a political decision. It stays a political issue. My personal position about proliferation, we should go to 0 level of nuclear weapon, and that solves every issue on this proliferation. But to my opinion, indeed, we have to make the technically complicated. But if one is willing to do that, I mean, it can be deviated.
Professor Kakotka would like to make a comment on this.
I just want to make a comment with respect to the 100-year transition which was mentioned by Areva in terms of when you start using thorium in existing fleet of reactors, it will be, that's indeed true. You know, if you have an existing reactor core, particularly an operating reactor core, such transitions are slow, and of course, for it to become a large program, it does take time. I think we should recognize that that's important because that allows you to expand the experience, the scale of experience with thorium, both in the form of use as solid fuel, as well as its reprocessing, recycle issues if there is one. However, it would be wrong to restrict the approach to thorium utilization to only that part, because I think you also need the so-called call it lateral thoughts or call it disruptive thinking, where you bring in new technologies for as a new technology product on the scene, and that's what will really grow fast. And we should recognize that I think from the point of view of the total energy dynamics, and if at all climate change is a serious issue, then talking about times which are 100 years and beyond would in fact be too late.
Yeah.
So we need to do something in a hurry.
Thank you.
Thank you. Just to be clear, I made here, I would say, a reporting on what has been said, but I have my opinion also, which is that indeed, I think there are time scales which are related to existing technology, but we are in a dynamic system. And there is, for sure, evolution which is needed. We have to make those systems flexible to move also in their life cycle. And secondly, as you said, indeed, innovation should be also brought forward, but not, I would say, like for going against what exists, but as a complement and improving things which can happen more rapidly. And that I think we have also in this community to see that this way, and we are not fighting each other.